In today's lesson, we're going to talk about the distributive property. So before we look at that, let's look at our number routine. How do you know? Pablo says 8 times the grouping of 3 times m is equivalent to the group of 8 times 3 times m. Why? Are they equivalent? Let's think about it. So 8 times 3 times m. Is there another way to say that? That is saying, that is saying 8 times 3m. And what's 8 times 3? 24m. On this side, 8 times 3 is 24. 24 times m. Is 24 times m the same equivalent to 24m? Yes, it is. Another way we can test it out is let's replace m with 2. 8, so we're going to substitute the variable m with 2. 8 times 3 times 2. What is 8 times 6? 48. 8 times 3 is 24. 24 times 2 is also 48. So they are equivalent. This is called the associative property. In associative property, when you multiply or add, it doesn't matter if it's first, second, or third term, it will always be equivalent. So we're going to be talking about today the distributive property. But before that, we're going to be using some number routine. So using algebra to help us. So it says 2 groups of 1 plus 3. Here's 1. 1 plus 3. But we said 2 groups of 1 plus 3. So is there a symbolic representation? Or another way to represent this using equivalent expression? So how many groups of 1s do we have here? 2 groups of 1. How many groups of 3s do we have? 2 groups of 3. So 2 groups of 1 is 2, plus, what's 2 groups of 3? 6. And what is 2 plus 6 add up to? 8. Let's see if that is equivalent to this. What's 2 groups of 1 plus 3? 2 groups of 4 is also 8. So we can represent this expression like this way. I was saying you have 1 plus 3, 2 groups of 1 plus 3. So 2 groups of 1, 2 groups of 3. Let's try another example. If I ask you to solve this, what would you say this is equivalent to? 3 groups of 3 or 9. Let's see, we use algebra to help us here. We have 4, 1, 2, 3, 4, and minus 1. 1, 2, 3, 4, minus 1. 1, 2, 3, 4, minus 1. This has 3 groups of 4 minus 1. So how many groups of 4 do we see here? We see 1 group of 4, 2 groups of 4, 3. So it's 3 groups of 4. And how many groups of minus 1 do you see here? I see 3 groups of minus 1. Minus 3 groups of negative 1. So what is 3 groups of 4? 12. What's minus 3 groups of 1? 3. 12 minus 3 is equivalent to 9. So you can rewrite this expression as this expression, A equivalent. We just generated equivalent expression. Now, we work with numbers. Let's see if you'll work with variables. So we have 5 groups of G plus 3. So that's using our algebra tile. This is G plus 3. So we need 5 groups of G plus 3. Here's a third group of G plus 3. Here's a fourth group of G plus 3. And here's a fifth group of G plus 3. How many groups of G's do we have here? I see 5 groups of G plus how many groups of 3's do we have here? 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3. So we have 5 groups of G, or 5G's, plus 5 groups of 3, just 15. Let's look at our algebra now. Is this represented here? It's 5G's and plus 1 plus 1 here, there's 15 positives. So 5G plus 15. So 5 groups of the sum of G plus 3 is the same as saying 5G plus 15. Next one. What is 4 groups of the difference of H and 2? So we have H minus 2, but we need 4 groups of H of the quantity H minus 2. So here's H minus 2. H minus 2. Is that 4 groups? Yes, it is. So how many variables of H do you see? Or you see 4 H's. Minus, how many groups of 2's do we see here? 4 of them. Sorry. Yeah, 4 of them. 1, 2, 3, 4. So 4 groups of H is represented as 4H. Minus 4 groups of 2 is 8. And let's see, we see minus 8. 1, 2, 3, 4, 5, 6, 7, minus 8. Let's try an example. And you make a prediction here. What is 2 groups of quantity of x plus 5? There's x plus 5, x plus 5, 2 groups of it. Any prediction? I think it's going to be 2. My prediction is 2x plus 10. You know what? I'm going to use my algebra tiles to prove that is correct. So x, plus 5, 1, 2, 3, 4, 5, 2 groups of x plus 5. So I see 2 groups of x's, 2 groups of x's, plus 2 groups of 5, so 2x plus 10. Hey, I was correct. I wonder if there's a way to do this without using algebra calc. We're going to keep practicing. Eventually, some of you will figure it out. What is 3 groups of quantity 4 minus m? So we have 4, 1, 2, 3, 4 minus m. 1, 2, 3, 4 minus m. 1, 2, 3, 4 minus m. So 3 groups of 4 minus m. So how many groups of 4's do we see here? I see 3 groups of 4's. How many groups of minus m do you see? I see 3 groups of m. So 3 groups of 4 is 12 minus 3m. Let's see. Let's look at the picture. Is this what you see? 12, 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, minus 1m, minus 2m, minus 3m. It is correct. So now, can you try to do this without algebra tiles? So let's try this one. 7 groups of m minus 5. We have m minus 5, m minus 5, m minus 5, m minus 5, m minus the quantity of m minus 5, m minus 5, m minus 5. That's one quantity, 2, 3, 4, 5, 6, 7. So how many m's do you see here? I see 7 groups of m. Minus, how many groups of 5s do you see? See 7 groups of 5. So 7m minus 35. What about the next example? 4 times the quantity, 4 times the quantity of 5 plus 9. 5 plus 9, 5 plus 9, 5 plus 9, 5 plus 9. So how many groups of 5f's do you see? I see 4 groups of 5f's. Plus, how many groups of 9's do you see here? I see 4 groups of 9. So what is 4 groups of 5f's? 20f's. Plus, what's 4 groups of 9? 36. So we've done it with algebra power. We did it using representing it. But now, see if we could do it more mathematically. Distributed property is, think of the word of distribute. Distribute, like if you go to a pantry, or go to a, for example, just kind of distributing super feast in Houston at the Georgia Athletic Center. Some of you may have done this before. You distribute, what they do is will prepare a Thanksgiving on Christmas meal, and they distribute to those who want to seek camaraderie and fellowship with other mankind to carry. Um, so distribute is giving it out, sharing with others. So we see in this example, it says 4 times the quantity of 2 plus 7. So it's saying 4 times 2, or 4 groups of 2, that's what we get 2, plus 4 groups of 7. And that's how we got that one. So we were doing you're distributing from 4 to 2 and 4 to 7. Let's look at the next example. 9 groups of the quantity of A plus 3, or 9 times the quantity of A plus 3. So it's 9 times A, done, plus 9 times 3. So it's 9A plus 27. If you don't believe me, A plus 3, 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 A plus 1, 2, 3, 4, 5, 6, 7, 8. This is the ninth quantity. So how many groups of A's do you see? 9 groups of A. Plus, how many groups of 3? 9 groups of 3. So that's the way to do it. So let's see if we can do it now without algebra tiles and without drawing it out. 4 groups of Y minus 4 groups of 8. What is 4 groups of Y, or Y, or 4 times Y, minus, what's 4 groups of 8? 32. Again, if you don't really trust me, we could draw this out. Y minus 8, Y minus 8, Y minus 8, Y minus 8. How many groups of Y's do you see? 4 of them. Minus, how many groups of A's? 4 of them. 4Y minus 32. Let's try next example. 6 groups of 3G's plus 6 groups 6 groups of 3G is 18G, plus 6 groups of 7 is 42. Again, if you do not trust me, 3G plus 7, 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 1 quantity, 2, 3, 4, 5. This is 6 quantity. How many groups of 3Gs do you see here? 6 of them. 6 times quantity. Groups of 3Gs. Plus, how many 7s do you see here? 6 sevens. So 18G plus 42. And so this is just, oh, so we would do a quizzes here afterwards in order to practice our distributive property. The distributive property, you may use algebra counts. You may write them out like I did here to prove myself, or you may distribute it. like saying 6 groups of 3G plus 6 groups of 7. This is called the distributive